Okay, so hello everyone. So okay. So our second topic this morning is about TR471.
What I would do is, honestly, I would usually just share this.
Yeah, go ahead.
Because this
Yeah,
information
that
is
works.
almost, it's
Okay,
always.
so this is the agenda for this topic.
It connects, it'll do.
And in the first part, I would do a brief introduction about what is TR471. And also what kind of a role in TR471 in order to perform a speed test. Looks like you already know 471.
Oh, no, it was just good mark.
Oh, okay.
Man, I'm going Maya.
Yeah, okay. So also in the first part, I'll talk about how the TR471 measures speed, and also introduce some relevant parameter of TR69 in TR471. Okay.
One question.
Oh yeah.
So, this is only to be used TR69 right now, and it's not part of the TR with the
369.
Yeah, 369.
This is separate, yeah.
Okay.
Let me explain what it is first, because it's basically speed testing, and then, yeah, you'll be able to use this with TR69 or TR369.
Okay, so that is not dependent just on TR69, right?
Yeah,
Parameters
the
in-
example they give us just CR69.
Okay.
Yeah. Okay. Okay, so in the second part, we have some case study about the feature that exists on our list model. And this model actually is a 5G model used in Europe. And also the feature of the TR471 is still under developing, but I think they will soon add to more CPU devices to support this function in the future. Yeah. Okay. So okay, so I move around.
Wrong comments, okay.
Okay, so let us begin with the first part, the TR471 standard. Okay. Okay, so before starting, let's have a discussion why the speed test is important for ISP devices. Okay, and the reason why measuring throughput is a quite popular topic is because the consumer and regulatory bodies are asking the ISP to deliver the SLAs. This one. And the term SLA stands for the Service Level Agreement, which is referred to a contract between the ISPs and their client. And this document might contain several points, like the detail of the service, and the standard the ISP must adhere to, and also the metrics to measure the service quality. Okay, and since the throughput is a main indicator for customers when measuring the ISP service quality, so that's why it makes a speed measurement become popular and it's so important. Okay. However, due to the original speed test program, we currently have such as TR143 was in a TCP-based design. And the TCP-based, and this characteristic will react conservatively to loss and round-trip display. And also, this behavior will underestimate the maximum capacities of the IP layer. So right now, that's the reason why there are more and more speed test programs and gradually switch from TCP-based to UDP-based design.
Like group, like for example, I've heard.
Okay. Okay. And as a demand of the, it's not clear. Okay. As a demand of the UDP-based speed test program is raising, and broadband phone launched a project called the OBUDPST, which stands for the Open Broadband User Data Protocol Speed Test. And this project is aimed to address the growing demand for the low latency and the gigabit service rate in fiber deployments. Okay. And things of the result of the speed test is a measurement between the two devices. And in a TR, as we can see that in a TR471 scenario, And the exhibit will act as a sender or receiver like this. And if we want to perform a uplink speed test, you will see that our PC, for example, will act as a sender in this test. And if we want to perform a downstream task, you will see that our PC will act as a receiver in the scenario. And once the test result is finished, the receiver will help to calculate the result and display to the sender. Okay. And as we already know that TR471 is a UDP-based speed test program. And in order to,
Hey, Mark. Do something with the TV remote so it doesn't.
oh yeah, because otherwise you will shut down.
Yeah, turn the volume up or down or something.
Oh, turn on and turn on.
No,
turn-
just the volume.
Just,
Oh, okay.
just hit the volume button.
Oh, okay. Thank you.
Yeah, just like.
Yeah, because yesterday suddenly
Yeah.
closed. I don't know
I
why.
just missed the wording. Yeah, okay, that's fine.
Oh, okay. Thank you.
Just basically give us some activity sort of.
Yeah, so here's the volume.
Oh, okay.
I'll do it.
Thanks.
Yeah, I see it.
Okay, so because of the TR471 is a UDP-based test program, so in order to let the sender and the receiver be able to support the maximum IP capacity during a task, we needed help from the task controller to periodically control the sending rate of sender. And you can see that the task controller has to be on the position either on the sender side or the receiver side, depends on each vendor's design. And the task controller will help to get the result in each speed test. For example, if the packet load is packet load rate is quite large during this measurement test, it will send the result back to the sender to tell us that the sender has to lower down the sending rate in order to perform a maximum IP capacity test. Okay. Okay. And how does TR471 measure speed? And before we talk about how 471 do, let us talk about what is TR143 do. And the way how TR143 measures speed is that TR143 only subtract the transmit byte count from the starting time to the ending time.
Yeah.
And the list design is make it impossible to understand following information such as a variation in the speed during the data transmission or provide a feedback on packet loss or delay in a complete transmission. So since 143 did not provide such information to the sender, the sender can adjust the sending rate dynamically because the sender don't have this information. So that's why the TR471 comes on. Is that the 471 want to solve this current situation in 143. Okay, so in the TR471, we already know that TR471 is into determining the maximum traffic capacity between the sender and the receiver. And for the purpose of a speed adjustment, the TR471 supports those functionality that TR143 has not. And for example, the graph I illustrate here is a time and trail result for a TR471 test during a single search for the maximum IP capacity test. And there are several terms we need to know in a TR471 technology. The first one is a search. And a search in TR471 is refers to a single measurement like this. And it represents the result of an entire TR471. And when a search is finished, we can get a result of the maximum capacity value during the entire test interval like this. And also, the search will also provide us the information such as the corresponding packet loads and the delay values. And the second word we need to know is about the interval. The time spent in one search that we call it is the interval. And an interval can divide it into several sub-intervals like this. And also, during each sub-interval, there are many adjustments of the sending rate and subsequent measurements feedback report from the receiver to the sender. And we code this information as a trail like this. And the trail is quite important because the trail offers an input for the load adjustment algorithm to the sender. You need to minimize the packet loads and keeping the delay value below a set threshold during the measurement test. Okay. And that's another what we need to know about TR471. And aside from the first definition of these two that we might already know, we can see that the search in TR471 is also represent the testing algorithm running on the sender. Okay, and we can see that it totally have two kinds of algorithm running on the sender. The first one is a search algorithm. And with the help of a search algorithm, it can help to adjusting the sending rate according to the feedback we got from the receiver. So that can help the sender to provide a minimal packet load and make the delay variation less than a configured value. And the other algorithm is the fixed rate algorithm. It means the sending rate of the sender won't be changed during the whole measurement test, because it will keep in a fixed rate during the whole measurement test. Okay, and the last one is a buying model. The word is talk about, it means the program will separate the test interval into two parts. For example, maybe if we enable a buying model test in a TR471 speed test, we will see two different results for two different subnets. For example, like this. For example, if we will have the first interval in this time range, this might be our first bimodal test, and then we will have another result for the second interval, the test result with second interval. We will look in more detail in the later slide what the display look like. Yeah, thank you. Maybe my description is hard to understand. Okay. Okay, so now I'll introduce the parameter when you set on the devices. Because before we ask the sender and the receiver to start the measurement process of maximum IP capacity. And there are several parameters like we can see we need to set on the devices in order to perform the test. And there are two kinds of category of the parameter. The first one is a connection category. And for example, you can see there are several parameters belonging to this category, such as the interface, which can tell us the interface will be used in the measurement test. And also the second one, the role, which can tell us whether our devices is as a sender or the receiver during the speed test. And also there's another information such as the host IP address and also the port number of the host. This information is also important as well, because you need to know your devices where the remote host is, so that you can perform a speed test with a remote host. Okay, and the last one is about the protocol version. That can help to assign whether the connection will based on IPv4 or IPv6. And by default, the default setting on our devices is set in any. Okay, and this slide shows the test-related parameter, include this four. And the first one that we might already know is talk about the algorithm running on our devices. It could be the search algorithm or the fixed rate algorithm. Okay, and the second one is that we can use the parameter to enable a specific function like enable IPRR or enable RIP on our devices. And IPRR is an abbreviation of the IP package reorder ratio. And with the help of this parameter, we can get a ratio of the packet that need to be reordered when receiver receive it. And also we can use another parameter to enable the RIPR on our devices so that it can represent the extent to which received packets are duplicated. Okay, and about the sending rate, you can see that we have two kinds of sending rate parameter is able to set. The first one is a start sending rate index. And this parameter is like we select a predefined rate with a specific index from an exist table. And the index is ranged from the 0 to 1110A, which is not displayed here. Okay, and the 0 in this table means that we using the 500K bit per second to doing the test. And the other one, the 1110A, means we use a 40 gigabit per second to perform the speed test. And if we want to type in the value manually, we need to use this start sending rate parameter to help us do that. Because if we use this one, it means we need to select from an exist table.
That's not confusing.
Oh, not confusing?
The index is a bit confusing.
Yeah. Select, it's more like you select from a predefined table when you
Yeah.
use the first one.
Yeah.
Okay.
If you happen to have that table in front of you, sure.
Okay. Oh. Okay, and okay. And the rest of the parameter I list on this slide are for setting the testing interval. And it could be the first one, the test subject interval, like you represent the time spent in each interval, like the display here, the DT. And this parameter is measured in a millisecond, ranging from the 100 millisecond to 6,000 millisecond in this range. Okay. And the other parameter is a number test subject interval. And we can see that the range is from 1 to 100 here. And we can find the cross-depending value on this illustration as well. The parameters can help us to setting the number of the measurement interval during our measurement test. Okay, and the next parameter we can set is a number first mode test subject interval. And here's an illustration about what is a bimodal test. As you can see, if we enable the bimodal test in a TR471 measurement test, the devices will send us two results. First result is in the first bimodal range, and the other one is the second bimodal range, like this. And also you can see the range of this parameter is from 0 to m value like this, where the 0 means we disable the bimodal test on our devices. And also the reason why it shows n like shows here is because the value n must be smaller than the value we set in the test subject interval. Okay, and here are the example of the TR471 parameter that we can set if we want to do the similar things like 471. For example, if we want to set the first model test subject interval, we can use this parameter to help us do that. And if we want to set other setting, like the test subject interval, we can use this one to help us do that. And if we want to get the result from the measurement test, we can use the get method along with the parameter list on this slide to help us get the information such as the configuration setting on our devices. For example, whether our CP devices is either the receiver or sender during the test, we can get this one. Or we can get the first mode test subject interval value with this parameter.
These are TR98 data models. So what does it look like a TR181?
181.
The sign just put device.
Device instead of the internet gateway
Yeah.
device.
Hmm.
Okay. That's what I was expecting.
Okay, and also we can get user parameter I showed here to get the result from each subinterval. And what's more, there's another one called model result test. Is that we can use this parameter to get the maximum IP capacity among several subinterval.
I'm sorry, but which one is the real result for the test? Is the subinterval or is the model?
Oh, this is one more. If you want to get the test from a specific subinterval, you use this one. And if you use this one, it can help us get the maximum IP capacity among several subinterval, not only one. Yeah, that's a difference.
So the average result will be the model.
Agree?
The model result, it will be like an average result.
Oh yeah, because from several subinterval, not only one. Okay. Okay, so now we have some case study about current function on our devices. Okay. And currently they implement the function on our NR7101 devices. And this is a panel looks like on our devices at the moment. As you can see, they implement this function on the diagnostic functional page of the devices. And if we want to perform a TR471 test, we need to select the test method from the drop-down menu here. And also you can see there are several parameters listed here that we might need to enter to perform the test. And in the later slide, we will see in more detail what's the parameter for. Okay, so this is our first case. So what should we do if we want to set our CPE as a sender to perform an uplink test? Oh, sorry, my PowerPoint crashed again. Yeah, I don't know why, always crash.
Microsoft, that's one.
Yeah. Okay. Okay, so I carry on. Okay, so since our first case is to see how we can perform an uplink test. So as we already know that we need to enter the host IP address and the host will act as a receiver during the test. So that's why the reason we need to select the sender as a role on our CPE device in this case. And also we can see there are several interval related parameters we can set on our devices. And we might already know that the meaning of these three parameters is represent for example, the first one. If we want to perform a bi-model test on our devices, we can set a value, a non-zero value in the field. If we set a 0 in this field, it means we disable the function on our device. Okay. And also we can decide what's the total number of the test subinterval we would like to perform in this test. For example, if we want to have a total 10 subinterval in the test, we can enter the value 10 here. And what's more, we can also decide what's the test subinterval be like in each interval. And the range, as we already know, the available range is from 100 milliseconds to 6,000 milliseconds here. Okay. Okay, so after we decide what the parameters are, we can just click the start button to perform the test. Okay, and the result of the test will show like the screenshot. And the display of the task can be found on the top of the page, this column. Okay, and as you can see, that there are several information we can get from the task here. And for example, the first one is that we can see the version of the TR471 being used on RCP devices. And please note that the version running on RCP device, running on the sender and the receiver has to be the same. Otherwise, the test cannot be performed and cannot be processed. Okay.
When you start the test, then negotiate the version being used?
Yeah, because the version is not matching, the platform will not start. So yeah, there will be a negotiation process before the test starts. Because we have other cases shows later. What's the error we will get when a version is not matched? Yeah, we'll see in a later slide. Okay. Okay, so the other information we can get from this display is one. It's like we can realize what the task we are currently doing. And if we are doing an upstream task, we are able to find an upstream task string shows here. Okay, and the task result of each subinterval will show a display like this. And the result can tell the user what the success delivery rate was during this subinterval. And also we can see that there are several items listed in the message as well. For example, the first one, the loads. The item refers to how many packet loads during this transmission. And also the second one, the OOO, which is an abbreviation of the out of order that indicates packets are received out of order. Okay, and the third one, the DUP, which indicates the reception of a duplicate packet. And the next one, the OWD bar, is referred to the variation in a one-way delay, which is a time taken for a packet to be transmitted across a network from a source to destination. And there's another one, the RTT, which means a round trip time. And it's a time taken from a packet to travel from sender to receiver, and a time from the receiver back to the sender. Okay, so when we scroll down to the bottom of this page, we were able to find a summary of the total test at the end like this. And aside from the total test result, we can see other information with a bracket like this too. So you can see that in this case, we enable a bimodal test function like this, which means the first three subinterval will be added as a first bimodal test. And the second, which is we can get a value from by minus 10 minus 3 to get a 7. And the 7 will be a range of our second bimodal test in this example. Okay. And the reason why we need sometimes why customer want to perform a bimodal test is that we can realize is that we can see that, for example, in the beginning of the test, we can see that capacity is still in a low rate at the beginning. So that's why, so it will make the result minus, so you might underestimate the result at the beginning. So that's why the reason they want to have a bimodal test in a TR471 measurement test like this. Because in the second part, you can see the rate is much more like the
Much more average.
yeah, thanks. So that's why they want to perform a bimodal test in some cases. Okay.
So right here, someone you're able to subtract that first sub-interval, so it doesn't count when the speed's going up, it's gonna start counting at the top and start that test there. You take that first sub-interval out, is that what you're doing right here with the?
What it does is
Yeah.
basically those two different tests at the same time. It's like, here's a test for, packets for sections 1 through 3. And then for intervals, I'm sorry, yeah, intervals 1 through 3, here's your total. But intervals 4 through 10, here's your other total, basically. So you can take those as two separate tests, so they're not even added together. Just basically, you're running two separate tests at the same time.
Yeah, so,
But you wanna input that information on that page to say, I want this test to start at this or sub-interval.
Yeah, that's what you're showing, yeah.
Cause he's got 10 and 3 minus.
Yeah, so if you go back to the
Hmm.
page where you put in the bimodal test, you can see
Yeah.
that. So, yeah,
So where does it say he wants
So
to start
there's the
four
fixed
with?
sub-
so it means that, the range of the first bimodal range will be 3 and the other one will be 7. Because
So you'll start at 7.
we'll have 2 results, one is from 1 to 3, and the other will be 4 to 10. Yeah.
4 to 10.
So you're talking about the first 3 subintervals and then the next 7
Up to 10.
subintervals
Hmm.
for a total of 10.
Oh, yeah, so that's why we see the value in this bracket.
Yeah, you can actually see the intervals right there.
Okay. Okay, so this is our second case. And what we need to set on our devices if we want to perform a downlink test. And since the case is nearly the same, but we only need to make sure that the row we set on our devices this time is a receiver. And the information the display of the information will be similar as the previous case. Okay. Okay, so now I'm going to introduce some troubleshooting method. What we can use to debug this TR471 issue. Okay. So this is our first case. What happens if we incorrect server IP address? We type in an invalid server IP address on our devices. And when such situation happens, we will see that the server error message shows on a result column here. Okay. And this is a second case. So what happens if we type in the correct IP address, but still cannot perform the TR471 test? And when such situation happens, they suggest to check what's the running version of the UDP-ST program on your remote host.
UDP speed test, basically.
Yeah. And how we can check that information on the Linux server is that we need to access the Linux server and type in this command. So that we can check whether the process is still running on our server or not. Okay, and this is a third case. It's about the different UDP SD code, the version difference between the sender and the receiver. And when such situation happens, we was able to find error message shows like this, that it tells us the version between the server and your CP device is not match.
It's not the case. Unavailable, that happens.
Okay. Okay, and also we can use this command if you want to check what's the current running UDP-ST program version on our CP devices through the command line. We can access our devices through a SH session with a root account. Then type in this command so that we can get the information. Okay, and here are some mistake proofing functions they also designed for this feature. Okay, so this is the first one. So what happens if we enter the value like greater than the available range 100 in this field? When we type in, for example, if we type in 300 here, we will get an error message like this. Like will tell us the available range should be in 0 to 100. Okay, and this is a second case. So what happens if we type in the numbers, the value of the number first mode test up interval is greater than the value we set in the number test up the interval. This is the error message we will get this time. As you can see, that it will tell us that the value of the first mode test up interval must be less than the number test up interval. And this is the reason. Because from the display here, we can easily understand why the error message comes out. Because the red part I mark here, it represents the first mode test up interval. So you can see that if the value we enter here is greater than the test up interval here, you will make the whole TR471 measurement process unable to run. It's more like a logical error. Okay. Okay, so this is the next one. What happens if we enter the value like greater than 100 in this cell? We will get error message like this. Okay, and this is the last one. What happens if we type in like value greater than 6,000? If we type in like this case, we'll get an error message like this as well. Oh, okay, so the topic is end. Thanks everyone. Thank you. Oh yeah. And sorry, and because this function is still, I think it's still under developing by our RD team. So we don't have a demonstration here today about the full cycle one. Yeah.
Did I see that it's gonna be able to be used up to 40 gigs?
Yeah.
40 gig.
Yeah. that's what
Oh
it's
yeah.
on there.
If you, yeah, you can use this parameter to do that.
What happens if they're already talking about 50 gigs?
This one.
That'd be.
Yeah.
TR
25 G. You can,
TR dash 999.
it's just fast food. You
Access
didn't have a version there, right?
TR471.
Oh, for the
EIS.
topic today, I will
But
send you
for
later.
CPU,
Because we
I
have
think
a
we're good
quiz
up to
they
40.
have in the open book test. Yeah.
Cause I wanna start reviewing.
Oh, okay, okay. I can send you
Next year.
right now. Yeah, to send to everybody about two topics.
Cool,
thanks. Okay.
And then how about the one from yesterday?
Already
Yeah,
said, yeah, already said,
said.
yeah, already said.
Sorry.
Yeah, it's okay.
Does somebody wanna take him to Blake's barbecue for lunch? I was kind of curious talking about pork one. I've got a previous engagement this afternoon.
So York, do you want tacos or barbecue for lunch?
There's no wrong answer.
Yeah, they're both a good one.
Yeah, that's good, sounds good. Sorry, what's another one? A burrito? Or-
Barbecue
Oh, barbecue.
is like.
Oh, yeah, I know barbecue. Yeah. I think I would prefer barbecue. Yeah, sounds good. Yeah. Thank you.
A brisket taco would be pretty good.
You can do that. Fusion.
I mean,
That'd
they
be
did that with
Tex-Mex.
Korean barbecue
Yeah.
too.
Yeah, where's the Kogi truck though? I don't know.